In this video, we are going to study about congruences. So let us define what is meant by congruences. So we will say that A is congruent to B modulo n, where this A, B are integers and n is a natural number. So when I'm going to say that A and B are A is congruent to B modulo n, if the number n divides a minus b, so n should divide a minus b. In this case, we say that a is congruent to b modulo n. So let us see one simple example what it means. So I'm going to take n is equal to say 5, and I'm going to take a is 15 and b is 10. So what we will do, I want to check whether a is congruent to b modulo n. So I want to check that is 15 congruent to 10 modulo n is 5. Is this correct? Is 15 congruent to 10 modulo 5? It means I have to check that does n divide a minus b? This is what we want to check. This is the definition of a congruent to b modulo n. Means does 5 divide 15 minus 10? Is this correct? Means does 5 divide 5? And we know that 5 divides 5. So this is yes. So this means if the answer is yes, it means that the two numbers 15 and 10, they are congruent modulo 5. Okay, let me take one more example so it will be clear. Let me take n equal to say 7. Let me take a is 35, and let me take b is say 14. So is a congruent to b modulo 7? Means is 35 congruent to 14 modulo 7? This is what we are asking. So you should simply do what? You have to ask yourself a question. Does 7 divide 35 minus 14? So you have to take the difference between the two numbers. So what is the difference between two numbers? So here you see that it is 21. So ask yourself a question that does 7 divide 21? Yes, because we know that 21 when I divide by 7, the remainder is 0. This means the answer is yes. So 7 does actually completely divide 21, right? So this means that the two numbers which are given to us, 35 and 14, they are congruent to each other modulo 7. So the answer is yes. You may sometimes get an example where the answer is no. So let me take n equal to suppose 6. Let me take a equal to say 20, and let me take b equal to 15. So is a congruent to b modulo 6? This is what I'm asking. So is 20 congruent to 15 in the modulo 6 relation? So it means you have to ask yourself that does 6 divide 20 minus 15? Is this correct? I mean to say that I'm asking that does 6 divide 5? We know that 6 cannot divide the number 5. You cannot divide the number 5 by 6, right? So this is not possible, right? So it means that The answer is no, and therefore 20 cannot be congruent. This is what I'm going to use to write not congruent. 20 is not congruent to 15 modulo 6. Okay, I hope now that how two numbers are congruent to each other, how to identify them, that is clear. Now let us see one small example, which will be like a theoretical example. So if I have three numbers with me, okay, suppose I have, let me take modulo 5. Okay, let me take three numbers A, B, and C. Okay, let me take A is 10, B is 20, and C is 30. Okay, let's take these three numbers. Now, modulo 5 is 10 and 20. Are they congruent to each other? If I take 20 and 30, is 20 congruent to 30 modulo 5? Let's ask us this question. Is this correct? Is this correct? So, does 5 divide 10 minus 20? This second thing is saying, does 5 divide 20 minus 30? It is the same thing to ask that, does 5 divide minus 10? And does 5 divide minus 10? Is this correct? Does 5 divide minus 10? Can you divide minus 10 by 5? Yes, I can divide it by minus 10. I can divide it by 5 because it is minus 2. So then the remainder will come to be 0. So minus 10 is 5 into minus 2. So this is the division. Minus 2 is the quotient. And the remainder is 0. So this answer is yes. So 5 actually divides what? 5 actually divides minus 10. So that is correct, right? So now I can surely say that 10 is congruent to 20. This is also correct. And 20 is also congruent to 30, right? So you see that A and B are congruent. 10 and 20 are congruent. 20 and 30 are also congruent. 20, 30 are also congruent. So we can now say that A and C are also congruent. 10 and 30 are also congruent, right? So if A and B are congruent, A is congruent to B and B is congruent to C, then I can conclude that the number A is also congruent to C, right? So let us try to justify this in a small way. So let me write the problem here. If ABC are integers and if n is a natural number which is positive, and if A is congruent to B modulo n, B is congruent to C modulo n, then I must be able to show that A is also congruent to C modulo n. So if A and B are congruent, B and C are congruent, then A and C are also congruent. Now the solution is very easy actually. So let's use this first part which is given to us. A is congruent to B modulo n. The meaning of this is that by definition n divides A minus B. So let's call this equation 1. Let's call it 1. And I know that B is also congruent to C modulo n. So by definition, I can say that n is dividing B minus C, right? So we have n divides A minus B and we have n divides B minus C, right? And we have used this somewhere we have used in the divisibility videos. We have already written one very important property. If you remember, if you have A divides B and A divides C, then you can always say that A divides B plus C, right? So here I have, in this case, I am having A divides A minus B and I have n divides B minus C. So using this above property, I can say that n divides the addition of both of them, A minus B and B minus C. So n divides addition of them, But in that addition, this BB gets cancelled, and you have what? You have n divides a minus c. And if n divides a minus c, so by definition of congruence, which we have defined, you can see that this a and c, they must be congruent to each other modulo n, right? This is what we have done in the definition of congruence. If you remember the definition of congruence was saying that if you want a congruent to b modulo say n, it is the same thing to say that n divides a and b ka subtraction, the subtraction of a minus b, n divides a minus b, right? So if you have n divides a minus c, it means that this number a and this number c, they must be actually congruent to each other. Okay, so this is how we have proved that if a is congruent to b is congruent to c, then a and c are also congruent to each other. So a is congruent to c modulo n. In the next video, we will see some more properties of congruences.